Hi everyone, and welcome to the Iceberg, your attack surface just got bigger, how to mitigate risk in your open source software projects. So first of all, let's set the scene and let's understand a bit more what is open source software. So the term has been coined in 1998 by Kristen Patterson, and the definition is source code that anyone can expect, modify, and enhance, and it's usually regarded as stable for long-term projects and also considered more secure than proprietary software because people could potentially raise a PR and enhance the code. Unfortunately, there are some cybersecurity challenges. Let's see one of these this challenge. So one of them is malicious packages, which means that a malicious actor will inject malicious code into a software product in order to compromise dependent systems further down the chain. Here we have the example of a package named Fall Guys, and usually the malicious actor will try to surf on trends, and in that case, this was quite a popular package during the pandemic, and users might think that by installing this package, they'll get some sort of advantage in the game. Unfortunately for them, this package is malicious and it attempts to read local sensitive files and try to exfiltrate information through a Discord webhook. That was the entry point in that case. So this is now under the umbrella of supply chain attacks that usually affects all ecosystems, unfortunately. And this usually happens when someone infiltrates your system through an outside partner provider with access to your systems and data. So as I mentioned, this doesn't only affect JavaScript packages. This is an issue for all ecosystems. And we did have an example in 2021 with Log4Shell within the Java community that actually hits a lot of companies. And usually supply chain attacks are quite attractive to hackers because when commonly used softwares or packages are compromised, the attackers could potentially gain access to all of the enterprise that use that software. So let's have a look at a bigger chain. So here you have a software supply chain from coding to the consumer. And you can see at the coding stage, a few more attacks. So dependency confusion, typo squatting. This also is to trick the user to download malicious packages. It's always the same patterns, try to exfiltrate sensitive data. And you can see at the end of the chain, some examples with Kutkov and SolarWinds, and this is to compromise a software to have access to a lot of these companies that are actually using these softwares, should be Kutkov and SolarWinds. So this is quite lucrative actually to exploit, as you can see and you can imagine, for a hacker. So let's try to understand what is going on and why we need to protect. So let's say hi to the iceberg, and you might wondering, what are you talking about? What is the iceberg? So this is the iceberg. Let's say hi. And actually, it's a great analogy to define the different layers that you have within your code base. So if you have a look at the application code, which is the tip of the iceberg, the application code is usually what you write, the code that you write within a company, and it's composed of all the components that, for example, the application user interface, the business logic, the functionality, the behavior. So here you have a piece of code to import a dependency, but this is actually the code that you're writing within a company. This is your code. Moving below this layer, we have the open source code. So here, if we think about how many lines of codes we write ourselves versus the number of packages we import to cut down the time we spend coding, actually, we don't want to reinvent the wheel because this is totally understandable. Why we would want to waste some time to write something that it might potentially already exist as a package in our ecosystem. So in this layer, this is composed with all of the components, libraries, framework that we're using. Unfortunately, by importing some packages, we might also introduce new risk. And this is, as you can see with all of this little package on the graph, this is actually increasing also your attack surface. Below this, we have containers. So the container layer is because an application is to be deployed somewhere. So we might be using containers and static website to deploy our projects. So we have different ways to do so. We can use Docker, Versal, Netlify, and all of the cloud providers. And if we're using Docker, we're adding a Docker file to our projects, which has metadata about our project. But again, this is an additional layer that we need to take into account, which is also increasing the complexity in the attack surface. And lastly, the last layer is infrastructure as code. So IAC is meant to simplify large-scale configuration and management. And usually we do provision our resources through code instead of manual processes. So this is great for making our codes as our single source of truth, where we can specify explicitly through code all of the infrastructure that is needed in our config file. We can have version controls, we can test and monitor. fortunately, again, this might potentially have some security misconfigurations in that case for ISC. So now we have a better understanding of what the modern application looks like, and also a better understanding of the new risk profile. Because we do realize that actually the application code layer represents only 10 to 20% of our code base. And the rest, 80 to 90% of the code base, is comprised from the open source libraries, the continuous images, and your IIC config file. Hence, it's actually quite important to secure and have guardrails at each stages of your pipeline to spot vulnerabilities as your attack surface is getting bigger. So you can do so from the coding phase, from implementing in your IDE up to the production. You need to scan your packages, you need to scan your code. So you have all of these stages that you need to cover during your development cycle. So let's see how we can do so using the same context that we have within a company to apply it to open source software. So the good news is that you might find a few of these tools on the GitHub Marketplace. So those of you who don't know what is the GitHub Marketplace, it has been introduced during the GitHub Universe in 2016. It's a place where developers can find integrations and implement them into their workflow. So there's a few things to take into account. So if you want to actually implement applications versus GitHub Actions, also what kind of programming language do you have? Because you want tools that actually cover and applications that cover your programming languages and the stack that you're using within your open source software projects. Also, if you want to use applications that are that have publisher badge versus no publisher badge. But the most important thing is to implement at least one tool for each of the DevSecOps stage. And what I would recommend also for this is to experiment, obviously to get the right tools for your projects. The good news is if you're working on an open source project or if you have a public repo, all of these tools will be free in that case. So experiment. So how can you leverage security tools to create a basic pipeline and implement guardrails? So as I mentioned, you can leverage those security application and actions which are available on the GitHub Marketplace to secure your pipeline at each stage of your development. So let's see this is how to create a basic pipeline with 3 steps. So this will comprise of a software composition analysis. This is to identify within the open source of your code base, is there any vulnerabilities? Then we'll see a tool to prevent secret spoilings, and we'll see a tool to cover static code analysis. So here, the most important thing is not about the vendor. It's more about, as I mentioned, the programming language. If it's covered, it's actually a good fit for your project. So I would recommend to actually test a few of them and see which one suits you better your project. So in that case, for the SCA, we can see Renovate or Sneak that actually will scan your dependencies files and let you know if there's any vulnerabilities. And usually those tools, they do have automation. This is what is expected when you're actually developing within your workflow. This is expecting that you would have potentially a pull request that will let you know at which version do you need to upgrade to. So here you can see, and it will give you advice to let you know which version you need to upgrade to. Obviously, you need to check because you already have your CI/CD pipeline in place, and you will need to run your suite of tests. Also, you'll have to set up some notifications just to get alerted if there's any new vulnerabilities. You can see examples of Dependabots and Sneak. So this will depend how many times you want these digests. It could be daily, weekly, or monthly, depending on how you set up your workflow. So the second layer, the second step that we would like to implement is secret spelling. So this is all of the unwanted distribution of secrets like API keys, credentials through multiple systems. And obviously, we don't want to have hard-coded credentials within our code base. So one of the tools that you could potentially implement within your open source projects is Git Guardian. And this is to flag any hard-coded secrets in commits and repository. And usually, so when you scroll down the product page, you'll see how to implement, and you will see that the tool is free for open source and public repo. And the next step is actually to implement it within your organizations versus to cover your repositories. And in that case, for Git Guardian, I would recommend, because we're actually scanning for and looking for credentials, is to scan all of the repos that you have under your organizations where you actually work for on your OSS projects. And to have this historical scan to give you any ideas if you do have hard-coded credentials. And also, obviously, you'll need to authorize and give access to this application. So the flow is the same for all of these tools when you integrate through GitHub. So this is the kind of dashboard that you're getting from GitGuardian, just to let you know if there's any secrets that have been found. So from the historical scan or from the Delta scan, so depending on your workflow, if it has been exposed publicly, if it's still valid, so you have all of this kind of information. Most importantly, what you need to check with these tools is what kind of integrations do you have. In that case, you can see that it's covering a lot of VCS integrations. So I'm talking about GitHub Marketplace in that case, but if you have the same structure on GitLab, you can also have a look on the marketplace and see what kind of tools you might be willing to integrate, or any of other marketplace that you have within your workflow. Also good to have the CI/CD integration. As I mentioned here, in that case, it's also a good thing to do the historical scan, but also to implement pre-commits. So before pushing to your repo and make it potentially public, you can see from your terminal that you're going to potentially push credentials, and it will be flagged as if. So this is also a good thing to have specifically for credentials. And I'll talk about chat ops, because you can see alerting, and this is actually great to also have this kind of features from these tools, and you can also implement within your team. And the last one is static code analysis. This is to examine your source code. So it's a method of debugging by examining your source code before a program is run. And this is done by analyzing a set of code against a set of coding rules. So here we have an example with Sonya Clouds. So depending if you want to install it on their cloud services, on the application, or if you want to use a GitHub action, again, this depends on the workflow that you have on your project or within your team of contributors and maintainers. And usually what you have is, again, the historical scan, and you'll have the Delta also just let you know if there's any new vulnerabilities that you've actually pushed from the pull request that's potentially one contributor has raised. So here, as you can see, there's some security metrics. There's also some security code, coding metrics on the, if you have any duplicates, if you have any code smell. So this is more on the development side, but what we're interested in here is more the security. And what I would recommend is when you are implementing these tools is to have a look at the kind of results that you're getting. So obviously, if you're having a lot of false positive, you might want to choose another tool that is best fitted to your project, but also the quality of the findings. And when you click on those findings, what kind of description you're having, and obviously if you have some remediations, because this is the most important thing, you want to fix actually the findings. So those are like areas that you need to have a look at before implementing these tools, or when you're using these tools, just to have that kind of feedback if it's valuable for your projects. Also, a lot of these tools are having heat maps and those kind of metrics. Just interesting, just to see what kind of area is well covered in your project. So if you love metrics and that kind of insight, these tools usually provide that kind of dashboards and tabs. Another good example is CodeQL from GitHub. And if you don't know how to set up the GitHub action and to have CodeQL into your workflow, the good thing is on your repo window, you can actually click on the action tab, and you'll have some templates. So this is a good thing. With one click, actually, you can set up the GitHub job. And here you can see with the YAML file, I know it's quite small, but at the bottom, it's just specifying the language. In this case, for this, I've used the OSJU shop. So the languages in the OSJU shop is JavaScript and Python. And you can see that it's actually flagged the correct languages. So in that case, you just start commits, and you'll have the jobs, the 2 jobs for JavaScript and Python that will be triggered, and you can go from there and see a few findings. So this is using Serif versions, but this is also a good way to also gather all of your findings and have a better view and start triaging just to tackle all of these vulnerabilities. So this is great, but how does it work on GitHub, you would say? I would consider the pull request as the source of truth. So when a contributor raises a pull request, this will trigger all of the application and actions that you have set up and implemented in your pipeline. So this is how it would look like. So depending on the different applications that you have, you will see some widgets popping up and giving you a little bit more info and what is the status for each. So you can see with Gatsby Cloud deployments, but also here if we talk about security, Sonya Cloud, apparently everything is green, which is great. But if there's any issues, you'll actually be notified here on the pull request. And when you scroll completely at the bottom of your pull request, you will see the list of all the tools that you've implemented. And then you can also set up, if you want to record it, you will set up the threshold. And you have to have those discussions with your team of if you want to have a good project, like a healthy project, this is also something that you might have to think of. So I was mentioning ChatOps. So ChatOps is a collaboration model that connects people, tools, processes, and automation into a transparent workflow. So for example, if you are using a free Slack account, you can potentially have the team of contributors and maintainers discussing on your Slack environment and have dedicated channels for specific tools. And this will help you having visibility on what is going on your project. So it's also great because you can set up monitoring and setting alerts. And it's also a vital piece where developers can help because they will get the right information on these channels. So this is how it would look like. So I'll give an example with, for example, Circle CI. Netlify, this is more on the CI/CD side, but for security, you can see with guardrails, you can see with Sneak and other tools, this is actually giving you this visibility. And you can also potentially gather a few tools on the same channel. This is up to you. This is an example with the GitHub webhook. In that case, this is great because you can see in real time with the color codes if there's any issues. And you can see here there's a couple of red lines. So the developers can actually see what is going on and can investigate through the pull request if there's any issues. Any documentation on GitHub? Yes, we need to talk about documentation. Yes, so when you are working on an analysis project, you can actually leverage the GitHub project to list all of the tasks that you have to work on a specific feature. You can create labels, as you can see on the left side, and epics. So here on GitHub, it's called milestones, just to track progress and for raising issues if you want to actually track more maintainers and contributors. You can also create a security label to track vulnerabilities in your project. So this is how it would look like. So obviously, it asks a little bit of discipline. Just to have under the milestone all the tasks, you can see the progress bar also. But more importantly, on the PR, make sure to tag correctly with the labels to assign it to the correct project and the correct milestones, and then you can see from there. And this is even more important because if you're actually this is supported with automated board, and you don't actually have to touch the card. It depends on the status that you have, if it's merged or not on the pull request. This will actually move automatically. So this is really important to have that due diligence on actually tagging the potentially your issues and features. So we've seen a few of the cybersecurity challenges. We've seen also the icebergs, as you have the understanding of the different layers that you have in your code base. We've also seen a few basic CI/CD, how to secure your CI/CD pipeline with 3 steps. Let's see a little bit of best practices and add some guardrails. The first one is to apply the least privilege principle. So this is to set the base permissions to no permissions on the member privilege sections, so they can only clone and pull the public repos. And this is if you want to give a contributor additional access, the maintainers will need to add them to teams and make them collaborators on individual repos. So basically, you create teams, you add users, and then you set specific repositories with specific permissions. Make 2FA mandatory for all maintainers. If you don't do so, actually this year GitHub is pushing and will require all users who contribute code to enable 1 or more forms of 2FA. So you have to enable 2FA, and it will be mandatory by default. Protect your main branch. This is to make sure to avoid any accidental deletion by a maintainer or by a malicious actor as well. And also at the same, if you click on edit, you'll see the different applications and tools that you've actually implemented. And you can actually select which one you want to record. So you can see this little label where it's written record. This is where actually you will set this. So again, this is a discussion that you have with your team, or if you want to actually improve the quality and the standards in your projects, you have those record before merging the pull request. Enable notifications and alert. This is if you have Dependabot enable or any of these tools, make sure to have the proper email address to make sure that you have that feedback as well to receive the notification. Review the different webhooks that you've actually set up. As I mentioned, because all of these tools are free, so you might be willing to experiment with a lot of them, but don't forget to actually delete the one that you are not using anymore. This is more like a security hygiene exercise, and you might never know, one of these application might unfortunately be compromised. This will potentially compromise your project, so make sure to actually remove the dead webhooks that you're not using anymore. Also, don't forget to check and add license. So analysis license protects the contributors and user. If you're not sure about the correct license to use, this is actually a good starting point here. And GitHub is actually giving you a few links to help you selecting the correct one. And you don't need to actually type it from scratch. You select the one that you want. This will be pre-populated, and there's a couple of few spaces here. You can see the year and the name for the MIT license that you need to populate, and you can review and commit, and this will be added within your project. And lastly, make sure to showcase your open source project status. This one is quite important. So it's not to brag about your project, it's more to actually demonstrate your project is in a stable state, it's healthy, and you actually take some time in consideration to implement different tools, not only on the code review and the code quality, but also on security and on compliance, obviously on the CI/CD status of your pipeline. But this is also to attract other maintainers and contributors, but just showcasing that your open source project is actually healthy and that is a good place to, it's a good project to work on. So I'll finish with a few key takeaways. So we know that open source is great. We're all using open source software and components. Unfortunately, sometimes it can be a vector for large-scale cyber attacks. I've mentioned the case of, because this was one of the biggest lately, the Apache Log4Shell. So having visibility throughout your pipeline using different tools and guardrails is critical to reduce your attack surface. And we have seen that leveraging the application available on the GitHub Marketplace can be a good starting point. And as I mentioned, if you're not using GitHub, if you're hosting on GitLab, you can also see what kind of options that you have there with the different tools and settings, just to make sure that you're also securing your CI/CD pipeline. And as maintainers and contributors, do not hesitate to create a small pipeline. Just as I mentioned, with 3 steps, you can actually get a good starting point, then you can build up from there. Experiment with some of the tools. As I said, if you don't like the tool, you can actually replace it with another one that corresponds better and suits your projects. Harden your GitHub project for everyone to be able to contribute to it. So yeah, experiment. But most importantly, please do not push your keys on GitHub. This is really bad. So I only had 20 minutes for this presentation, but if you are interested in diving more into this topic, I'd recommend one of the handbook that I wrote on this topic, which goes more into the different steps and walk through on how you would implement more of these tools. So this handbook is available in English, French, Spanish, and Korean. So I'm Sonya Moisset. I'm a senior security advocate at Snyk. I'm passionate about DevSecOps, open source, and cloud security. I do a few things outside of Snyk, but I'm not going to bother you with this today. But if you want to connect and have a chat, you can do so at Sonya Moisset on LinkedIn. Yeah, I just wanted to thank you for listening to this presentation. Hopefully you've learned a few things and how to secure CI/CD pipeline. Just give a little bit more interest in implementing some of these tools within your pipeline. And I would say just, yeah, stay safe in your journey to OSIS contributions. Thank you.